Welcome back. In this video we'll be going over some things that affect acidity. First off, what we know from Gen Chem is the KEQ equation as just products over reactants, or as we typically see it, like this. We will be using the A and HA in terms throughout the video. And we know that Ka equals 10 to the negative 40 to 160. Acids go off the pKa values, which you can think of pKa as negative log subscript 10 Ka. Or you could think of it as pH equals negative log of the H plus ions. The important thing to remember is that the smaller or lower the pKa, the stronger the acid will be. The acid strength is always related to how much the conjugate base wants that negative charge. When looking at the rules of acidity, there are 5 major rules to think about. The first is electronegativity. As the electronegativity of A increases, so does the acid strength of HA. When looking at a periodic trend, we can see that the electronegativity moves up and to the right on the periodic table, excluding the halogens, with fluorine being the most electronegative. We can also look at the electronegativity chart as this, and we can see kind of where everything falls into place. One example can be seen through comparing an amine and a carboxylic acid. So we have an OH group attached here, and an NH2 group attached here. Since oxygen is more electronegative than nitrogen, we can see and we know that the carboxylic acid will be the more acidic compound. Next is the effect on size on pKa. As the size increases, the hydrogen is more loosely held and the bond is easier to break. Also, a larger size will stabilize the anion, and in a periodic trend, we can see that the size moves down and to the right on the periodic table. We can see this by drawing a similar chart to that of the electronegativity chart we just saw. So when you look at it, this is literally just, you look at how the size increases, it increases the acidity along with it. The third rule being that as the number of resonance structures increase for A, so does the acidity of HA. Simply put, that if a molecule has more resonance structures than another, it will be more acidic. And if you're still struggling with the concept and the idea of resonance structures, you can definitely check out one of our older videos. The fourth being that electron withdrawing groups increase acidity, also known as the inductive effect. We can see this with the chart below. What this means is that the electron withdrawing atoms and groups can stabilize a conjugate base through a sigma bond of a molecule. The stabilization of a conjugate base will result in a stronger acid. You can think of the inductive effect as it depending on the number of bonds between the electronegative element and the site of the negative charge. The fifth rule, and the final rule, being hybridization. Think of this rule as the more S character, the more acidic it is. What I mean by this is that when looking at the atom's hybridization, you can predict its level of acidity in comparison to those around it. This can be seen with a few examples to try to strengthen your understanding as we see in the chart. As you see with ethane here, it has an sp3 hybridization because this carbon and this carbon are both attached to 4 different things. So what I mean by the S character up here is that the S contains 1 of the total 4, or 25%. And that would give you a pKa value of just a rough estimate of 50. And then when you go over here, same thing. It's now connected to 3 things on each side. So it has an sp2. The S is 1 of 3, as you see here, 33%, which is roughly 44. And with here, each one is attached to 2. So when you come over here, you have an sp, which is 1 of 2, half, 50%, or 25. we can see that when looking at the hybridization, we can compare how much the S character is to each other, and that's what gives you the relative percentages. And as I said, the greater the ratio between the S and the P's, which gets you the S character here, you'll get a lower pKa. If you found this video helpful, please check out some of our other videos on our channel. You can get an A in OChem, and we're here to help. Thank you so much for watching, and we'll see you next time.